So in this video specifically going to talk about what are the conditions which is very important in order to start the static inverter, and apart from that we will also talk about whenever there is fluctuation happening in the output power or in output voltage, how this fluctuation is getting controlled through inverter. In this video we are going to talk about both of this topic. So let me tell you, first of all, we have in our train, this basically there are two type of converter which has been used. First is the first is the traction converter, and second is the auxiliary converter. Traction converter is responsible for generating the traction supply, and auxiliary converter is responsible for generating the auxiliary supply. Auxiliary converter, sometimes it is also known as SIV or APS. So in SIV basically we have two modules, right? Basically we have two modules. First is the converter module and second is the inverter module, right? In converter module and inverter module both are separated with the help of the DC link. Now here one of the important point, inverter module is directly connected with the auxiliary loads. Now what are the auxiliary loads? Like for example we have three phase loads, and then we have single phase load, and we have 110 volt DC loads. We can also say auxiliary loads are the loads which require three phase power, single phase power, and 110 volt DC power. Like for example, if I talk about three phase power, what are the loads which require three phase power in our train? We have three phase compressors, and then we have three phase pumps. So these are the auxiliary loads which require three phase supply. And apart from that, 110 volt DC supply is specific for the train line signal. And then apart from that we have single phase 240 volt supply, which is like located in the driver's cabin for charging the mobile phone, and it is also located in saloon area as well for the passengers. When passengers require to charge the phone, then this single phase 240 volt socket supply is very important. So that's the reason this auxiliary converter is responsible for generating these three supplies: three phase supply, single phase supply, and then 240 volt single phase supply. So here we have to talk about, as I said, fluctuation. Whenever there is fluctuation happening in the output load power and load voltage, how this fluctuation is getting controlled through inverter, we have to talk about that first. And second, we have to talk about that condition to start the SIV. First let's get started with the conditions to start the SIV, right? SIV, static inverter. So start and stop sequential control of SIV is done by 16-bit microprocessor located in control circuit. As we have already discussed, in SIV we have different circuitry, like we have control circuit, we have ground fault detection circuit, right? So starting and stopping sequence of SIV is done with the help of a microprocessor, 16-bit microprocessor, which is located in control circuit. We have control circuit, and control circuit has the 16-bit microprocessor, and this 16-bit microprocessor is responsible for starting and stopping sequence of static inverter, right? We are going to talk about this starting and stopping sequence as well. What is the starting sequence and what is the stopping sequence, starting sequence of SIV? We'll talk about this as well, but in my upcoming videos. And we'll also discuss about what are the conditions in order to stop the SIV, in order to turn off the SIV. We'll talk about it in my upcoming video. So condition to start the SIV, as I said sometimes back, starting and stopping sequence is being done with the help of the 16-bit microprocessor, which is located in the control circuit. Condition to start SIV APS, control power supply. First of all, there should be control power supply. As I said, 110 volt DC should be available, right? And this control power supply 110 volt DC is getting available just because of this battery system which has been used in our train. This battery provides 110 volt DC, so we can say we have control power supply which is being provided with the help of these batteries, right? No major and minor failure have occurred. In order to start the SIV, there shouldn't be any major failure and minor failure which is already been persisting in SIV before it's starting. AC input should be greater than 300 volt 50 hertz. So these are the three most important conditions in order to start the SIV, right? So what we have understood so far, 16-bit microprocessor is responsible in order to start and stop the SIV, and this 16-bit microprocessor is located in the control circuit of SIV. And then condition to start the SIV, there should be the control power supply of 110 volt, and then no major and minor failure should be there in SIV, and AC input voltage should be greater than 300 volt 50 hertz. Then only SIV will get start. The sequential operation, or I can say SIV gets turned on when all these conditions are getting fulfilled, right? We'll talk about this topic in detail in my upcoming video. I'll be discussing about the same thing, so we'll get to know about what actually the starting sequence and stopping sequence of SIV. Basically we have two contactors, auxiliary contactors and main contactors. Now this concept AC input voltage should be greater than 300 volt 50 hertz. This point will also get clear in my upcoming video. So in this video I am not discussing about that much, like in that much depth, because video will become unnecessarily long. So in order to prevent the video to get like unnecessarily long, I am like keeping the thing simple as much as possible. Now let's get started with the second topic: how inverter controls the fluctuation happening in the output voltage and output power. As I said sometimes back, inverter is directly connected with the auxiliary loads, right? If fluctuation happening in the auxiliary load, if fluctuation is specifically happening in the output power and output voltage, then inverter is responsible for controlling this fluctuation, right? So here we are considering two fluctuation. First is the fluctuation in the output power, and second fluctuation is the fluctuation in the output voltage. So what will happen in both the cases, how inverter controls this fluctuation in both the cases, we have to talk about it. So let's get started with fluctuation happening in the output power. So whenever there is fluctuation happening in the output power of the auxiliary loads, then this fluctuation is feedback as a signal, and that signal is known as load current feedback signal. And due to this operation, inverter output voltage command changes. As we already have discussed about inverter output voltage command signal, inverter output current command signal, we have already discussed about all this thing, so I don't think so I need to discuss about the same thing again. So whenever there is fluctuation happening in the load power, then a signal is basically generating, and that signal is like a feedback signal named load current feedback signal. So this load current feedback signal changes inverter output voltage command, due to which inverter controls fluctuation happening in the output power, or can say load power. Now whenever there is fluctuation happening in the output voltage, then what will happen? Whenever there is fluctuation which happens in the output voltage, then this fluctuation is feedback to the voltage controller. We have discussed about the voltage controller, and by this operation inverter controls the fluctuation happening in the output voltage. So both the things are very simple. Whenever there is fluctuation happening in the output power, then this fluctuation is feedback as a signal named load current feedback signal, due to which inverter output voltage command changes, and due to this operation inverter controls the fluctuation happening in the output power, or can say load power. And here we have discussed about whenever there is fluctuation happening in the output voltage, then this fluctuation is feedback to the voltage controller, and by this operation inverter controls the fluctuation happening in the output voltage, or can say load voltage. So that's it for this video. In my upcoming video I'll be discussing about starting and stopping sequence of the SIV in a very detailed manner. So thank you for watching this video.